Scheduling project management by critical path method. So a network is used to represent a project is called a project network. So a network used to represent a project is called a project network. A project network consists of number of nodes and a number of arcs that lead from some node to another. For example, if we have a node is A, B, then the connecting edge is called is an arc. So this is node here, A and B are node, and this is arc. Now, in order to manage project management, scheduling project management, there are two methods, two alternative methods. One is activity on arc, AOA, project network, where activity is represented by arc. So here in this method, the arc is represented, activity is represented by an arc. And the second type of method is activity on node AON, the project network, where activity is represented by node. So here the activity is represented by node, and here activity is represented by an arc. Okay. So the most commonly used method is AOA, but the second method is much easier than first method, and it is now commonly used in uh, project management techniques. So we will use second method. So now consider a problem of management, project management. So I have given a table, the list of activities for reliable construction of a co-project. So here activity is given A, B, C, D, etc. up to N. These are the N activities. These are the number of activities, and this activity description and immediate predecessors is given. That means here A has no immediate predecessor. So that is A before A there is nothing to start. So this is start, and A has no immediate predecessor, and B has predecessor A. That means immediate predecessor is A. That means after doing A, then only we can perform B. So that means after done A, then only we can perform B. So similarly, C for C, there is B is the immediate predecessor. So C can be performed only after B. So this is C. Now, for D, immediate predecessor is C. Again for E, immediate predecessor is C. And again there is for I, immediate predecessor is C. So from C, after C, you can do B only after C, and and uh, and then E E we can do only after C, and also I. Okay. Now then D we done, E we done. Now F is can be only done after E. F can be only done after E. So this here F. So similarly we can complete the list. Okay. So here I will give in the list. So I will reduce this. So if I am copying this, so now look at here. So here here. So we done like this. So we must have a start. So this is the project network start. The duration, the value of start is 0, and then we have to do the first step, that is a a a. Now a, you had, it takes 2 weeks. Then then the b has immediate predecessor of a. So a is the immediate predecessor of b. So a, there is no another, a is not immediate predecessor of any another. So here we can put b, and their value is 4 weeks. Now after that, you have to check c. C has immediate predecessor b. So then then okay, then then c is the immediate predecessor of b, and we will write this value. Then okay, then we have c is over d. Immediate predecessor of d is c, and immediate predecessor again, c is immediate predecessor of e, and c is immediate predecessor of I, right? I. So we will get C is immediate predecessor of D, and we will write here, and their value is 6, and E is also immediate predecessor of C, and I is also immediate predecessor of. So we wrote this, and I. Now G is immediate predecessor of, or E is the immediate predecessor of, or F is the immediate predecessor of E. So F is the immediate predecessor of E. So here, similarly, sorry, E is the immediate predecessor of F. Now again, E is immediate predecessor of H. So E goes to H2. Then there is no another. So next, G. G is the immediate predecessor of D. G. G has immediate predecessor G. So D. So this. Now again, D is not immediate predecessor of anything. Now again, we have to check H. H is as immediate predecessor E E. H has E, and also H has G. So G also immediate predecessor of H. Now we have to find J. J in J, F and I are immediate predecessor. So F goes to here, and I goes to here. So similarly, J, J is immediate predecessor of K also. J is immediate predecessor of K, and also L. Similarly, we can complete this step. So this project network of above question. So we can do it. Now, critical path. Now next topic is critical path. So I will define what is critical path. So before that, I will define what is a path. A path through a network, project network, is one of the routes following the arcs from the start node to the finish node. So it is a path, is a project network, is one of the route following the arcs from the start node to the finish node. The length of the path is the sum of the duration. So for example, I will write a path here. So I will find a path from here. So there are many paths. So first is start, then A, B, B goes to C, then there is C goes to D, D goes to G, G goes to H, H goes to M, and finish. So this is a path. So that is start going to A, B, C, D, G, H, M, finish. And we can write the uh, required time. So this is for A, this is 0. For A, 2 weeks, B, 4 weeks, C, 10 weeks, D, 6 weeks, 7 weeks, H, 9 weeks, 2 weeks, and 0. So if you add all those things, so now we will check if there is any path like that. Okay, so A, B, so from here A, B, C, D, G, H, M, finish. So that is 40 weeks. So this is our week. Now similarly we can find another route, another path. Start A, B, C, then E, then H, then M, then finish. So there is another route. Similarly, start, then from here, this goes to here, here, here. So similarly, we can find all paths. So that is represented here. That is discussed here. So, so what are the paths? So that is discussed here. So these are the paths we got. So these are the paths we get, and their length is given here. Okay. So these are the all paths. Now, now from here, which has this long highest value? Which has the highest value 44. Then this corresponding that path is the critical path. So this path is called the critical path, which has the highest time value. So that is critical path. The project duration equal to the length of the longest path through the network. This longest path is called the critical path. So in this case, this is the critical path. Okay. And estimated project duration is 44. Now after that, we will use find scheduling individual activities. Scheduling individual activities. For that, we will discuss what is earliest earliest start time and the earliest finish time. So the starting and finishing time of activity, if no delay occur anywhere in the project, are called the earliest start time and the earliest finish time. So earliest start time is the starting time and earliest finish time is the end time where no delay occur. So we will represent it by E of S, ES, ES, the earliest start time, and EF, the earliest finish time of a particular activity. Now EF is equal to ES minus duration of the activity. Now we can calculate ES and EF for each node. So start here 0, and for node A, ES is the earliest finish time. Earliest ES is earliest start time. So earliest start time is 0 here, 0, and EF is earliest start time minus duration. So early 0 duration of the activity plus, not minus, it is plus, it is plus. Okay. ES plus. So 0 plus this 2, 2. Now for B, the earliest start time is this EF is 2. Now so 2 and ES is 2, EF is, so we will represent usually by this. ES is 2 and EF is 2 plus 4, 6. Similarly here ES is 6, the EF of the preceding, and EF is equal to 6 plus 10, 16. And here ES equal to 16, and here EF is equal to 16 plus 6, that is 22. And for here ES is equal to 16 and EF is equal to 16 plus 10, 26. 16 plus, 16 plus 7, that is 23. Okay. Similarly we can find. So now there is a problem here. Now if we continue like this, what will be ES of this? This is actually, okay, here there are two predecessors, G and E. Now we will take the maximum EF. So here maximum EF as ES of H. Here max EF of G is 29, EF of EF of E is 20. So we will take 29 and then EF of H is 29 plus 9, 38. So similarly here there are two nodes. EF of F is 25 and here 23. So we will take 25 and EF of this is 25 plus 8, 30. So similarly we will calculate all these things. So we will get a table. So this, so what is largest EF of the immediate predecessors? So we have taken largest EF of immediate predecessor. So we will get this 25, 33, 29, 38. Okay. Similarly, so H 38, 29, 38, 29. And similarly we get J 25, 25, 33, J 25, 33. Okay. Similarly we can complete this. Then at the finish node we get ES is 43, 44 and EF is 44. So EF for the finish node is 44 plus 0, that is 44. So this calculation indicates that the product should be completed in 44 weeks. Now if everything stay on scheduled according to the start and finish time of the given activity. Now there is one more thing. Latest start time for an activity is the latest possible time that it can start without delaying the completion of project. The latest finish time as corresponding definition with the respect to the finish. So LS is latest start time of the particular activity and LF is latest finish time of the particular activity. So LS is equal to LF minus estimated duration of a activity. To find LF, we will take the last time we taken the uh, So immediate successor, smallest latest value of immediate successor. So and LF is smallest LS of immediate successor. So we will start doing this. So we will start from the bottom. So I will do it from the bottom. We have to calculate LS LF equal to LS equal to. So LF is LS of this. So that is 44. 44. Yes, of 44. 44 minus 0. 44x. Now similarly here. So we will take here the LF is equal to 38 and LS is equal to 38 minus 2. 36. 38 is LS. Now 38 minus 2. 36. So let me check that is our we done it correctly or not. So this is LS and LF 44 44. So 38 38 and 40. 38 and 40. Sorry, 42 and 44. So 42 and 44. 44. It is I make a mistake. Okay, sorry. So what we done is here LS is 44, LF is 44. Now from here we will take LS is LF is smallest among these 44 and 44 minus 40. Now from here also we will take LF is 44 and 44 minus 6 38. Now similarly from here 40 38. So LS is now we will do that from here from this question. So we will get here 44 44 and 0. So LS is 44 44 44 minus 0 is 44. Now here 44 is the LS of LF of this and LS of LS is smallest LS is here 44 44 minus 2 42. And from here what is LS is 42. So 42 is LF of this and 42 minus 9 39. Okay, so similarly now for from here 33 is the LS, so that is LF for here and 33 minus 26 for G. Now similarly from here LS is 26 minus 6 20. Okay, and so on. Now what will happen from here? Okay, so here for this E or for this C we have LS values here. Okay. Now from these three nodes we have to take the least ls value. This, so 16 is the least value that we put as lf minus 10, that minus 10, that is 6. Okay, so similarly there here is also uh, okay, for here, okay, for here also the same situation. Now here there are L and K. So what are the LS and LF values? 34, 38, 33, 38. So the smallest value is 33. So 33 is the LF, and 33 minus 8, 25. So similarly we can complete all this activity. Now we define what is slack. Slack for an activity is the difference between its latest finish time and its earliest finishing time. So slack is LF minus EF. LF minus EF. So LF minus EF is for M. Here M. LF minus EF is LF is 44. 44 minus EF is 40. That is 4. 4 is the step. Now the critical path we already got. Now slack is 0 for the critical path. So what A, for A, what will be the slack? Slack is this A, 2 minus 2, 0. For B, 6 minus 6, 0. So A and B in critical path is 0. So C, for C, this 16 minus 16, 0. So C is also in critical path. Now D, what will happen? D 26 minus, that is 4. Slack variable is 4. That is not in the critical. Similarly, we can do all this. So similarly, we can find the slack variable. So this is how we can find project network. So first you have to draw the project network. Then you have to find the critical path, and then ES, EF, earliest start time and earliest finish time, and latest start time and latest finish time, and also last is slack.